Good afternoon. Welcome back. If you have been tuned in to our Spotlight on Stroke festival, we'll call it this morning. My name is Jillian Mason. I am a white woman with kind of blondie, regrowthy from the pandemic, long hair, and I'm wearing a colourful shirt for those of you tuned in who are blind or visually impaired. My pronouns are she and her, and I'm the manager of the Stroke Research Register at Hunter Medical Research Institute, part of the Uni of Newcastle, and we work with Hunter New England Health. I'm thrilled to be able to welcome you all here to talk about stroke research. So we've been in isolation, we've been spread out all over the country, and we can't see you in person, which makes me a bit sad, but it's great to have this technology to be able to talk to you about what's going on and we are inviting you to please share how stroke research has impacted you, what living with stroke is like, and what we should be doing in our research. So please join in the conversation. I'm broadcasting now in this little broadcasting studio, which is really just my office at home. I'm on the traditional lands of the Pambalong clan, and it's a Wabikal land here in Newcastle in New South Wales. And I want to respectfully acknowledge these custodians of this land, and as well, just encourage you to write in the comments, say hello and let us know which land you're on all around the country. What have we got in store? It's nice to see a couple of you joining in here and watching. But we've got a lineup of some of our stroke researchers. They're going to give presentations about some work that maybe you've been involved in or maybe you want to get involved in. Whether you're someone living with stroke or whether or not you're someone who knows someone who is, if you're part of the general community, we'd love you to leave this afternoon knowing a little bit more about stroke, having a bit more awareness, but also realising, and we spoke about this morning, that people who live with stroke do face significant challenges related to their stroke, but we need to be more aware of what those are so we can make societies more inclusive and accessible. So the first trial that we're going to talk about is a trial that's looked at making things more accessible. It's a trial using telehealth, and it actually wasn't developed just because of COVID. So this is some work that's been in the works for a couple of years now. And the researchers involved have been working with people with a lived experience of stroke to design together really effective ways of connecting with people all over the place in a convenient way. Before we jump into it and I hand over to them, just a little bit about the format of the day. So if you're watching on YouTube or if you're watching on Facebook, you can put a comment in the comment section underneath the video and it will display to us backstage. So that's the place to ask questions about the research. You can ask questions directly to the researchers and they'll be able to see them. And then if they're not presenting anything, we'll have a bit of a discussion. So just please feel free to get involved. The last thing about this, after we do a live streamed presentation session, just after 3:30, there's going to be an opportunity to talk to researchers. So we have a couple of chat rooms organised and there's opportunities to use the telephone if you don't like video chatting, to actually have discussions with the people who are going to talk to you about their research. So I'm really excited to be able to kind of steer the ship this afternoon. And yeah, firstly, it's my absolute pleasure to introduce you to two researchers who are health professionals. Carly Zachariah, she's a dietitian, she lives in Newcastle, and Emily Ramage is a physiotherapist who's in Melbourne. She is getting out of lockdown at 6 o'clock this evening and has kindly decided to use the last couple of hours of lockdown to speak to us. So I'm going to pop them up on the screen first, and then I'll get out of the way. Thank you so much for being with us.
Pleasure.
Thank you. Hi, my name's Emily Ramage, and we've got Carly as well. And we're going to be talking today about a program we've helped put together, I Rebound After Stroke. But firstly, I'd like to acknowledge that I'm giving this presentation from the land of the Wurundjeri people of the Kulin Nation. I also acknowledge the traditional custodians of the various lands on which you are today and the Aboriginal and Torres Strait Islander people participating in this meeting or webinar I pay my respects to elders past, present and emerging, and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of Australia. So now a little bit about iRebound. And first of all, we'd like to talk a little bit about where this project came from. And from a physical activity or an exercise perspective, we know that being inactive, being with low levels of physical activity is a risk factor for stroke. It can increase your risk of things like diabetes, high blood pressure and high blood cholesterol. But being physically active can improve fitness, walking speed and endurance after stroke. But not only can it help you to move better, it can help you to feel better. We also know that after stroke, many people have low levels of physical activity and could benefit from support so that they can be more physically active. One of the things we know might help is providing them with exercise sessions that are supervised by a health professional. Unfortunately, in Australia, we don't have any standardised programs to deliver this across Australia like they do for people who have heart or lung conditions. So this project was about developing a program that could support people to be more physically active. I'll now hand over to Carly to talk a little bit more about eating well.
Yeah, so hi everyone, I'm Carly Zachariah. I'm a dietitian and my pronouns are also she and her. And for those people in the audience today that are visually impaired, I'm a white woman with dark hair pulled back in a bun with black glasses and a black top. I feel like I'm about to do some kind of interpretive dance or something. I should have rethought my outfit. I'm also coming to you from Newcastle on Awabakal land, and also wish to give thanks and pay my respects to elders of the past and the present and those emerging and anyone of Aboriginal or Torres Strait Islander descent who's watching today. So yeah, in terms of diet and stroke, what are the things that we know? Well, we know that eating well can help to lower your risk factors for stroke, and in particular, the right overall diet pattern. So not necessarily individual foods. There's no one food that's going to be the wonder drug, unfortunately. It's all about having a really good diet quality and an overall pattern. And having that can help to manage things like your blood sugar or your cholesterol levels or your blood pressure. And that can all combined help to lower your risk of having a stroke or another stroke. But I guess if changing your diet was that easy, we'd have more than just the 5% of Australians eating the right amount of fruits and veg. So also, like physical activity, there are no diet programs that we could find anywhere that were designed specifically to support the needs of stroke survivors when we're talking about changing diet. And there's certainly also nothing that combines the two.
Now we're going to talk a little bit about how we got from what we're wanting to put together the project to the final product, iRebound. So we wanted to make sure our program was based on the best research, but we also wanted to make sure we were including the knowledge and expertise of those who were going to use it. So people with a lived experience of stroke, caregivers and healthcare workers. And we involved them from the beginning to put this together. So we had some healthcare workers and a stroke survivor on our research team, and we also spoke to lots of other stroke survivors and carers and healthcare workers to make sure it was going to work for them. In some of the workshops we ran, it became really clear that we needed to be able to tailor lots of aspects of the program so that it met individual stroke survivor needs, and we've really tried to put this into the program. People with lived experience of stroke also helped us to put together our resources to make sure they worked for them. So we've made them aphasia friendly. And one of the other big things we did was rename the program. So with a lot of great input, we came up with the name I Rebound, Let's Get Moving, because stroke survivors told us that's what this program meant to them. So in terms of the physical activity program, it provides 12 weeks of exercise supervised by a physio twice a week. And as Jill mentioned, that's run via telehealth. So we use video calls. So there's a health professional at their place of work and a stroke survivor in their home, and we have a video call a little bit like this to do the exercise sessions. And then after those 12 weeks, there's a further 12 weeks of support to support people to continue their physical activity so they can stay active and really get the full benefits of the program.
Oh, someone's going for a swim there, Em. That's beautiful.
Yeah, that's my background. I'm really sorry. Lost my...
That's all right. My slide looks almost identical to yours, so I could just chat about it if you like.
Okay.
So in terms for the diet part of the iRebound trial, we used exactly the same sort of co-design process to develop that program alongside stroke survivors and clinicians and carers as well. So we chose a Mediterranean diet pattern. Others will work. There's lots of healthy diet patterns out there. The best diet for you is the one that you can stick to, because health changes from a diet take time to accrue. So we want to make sure that you can, what we call, adhere to it for a longer amount of time. So we chose a Mediterranean diet because it has the highest amount of evidence to make sure that we can lower those risk factors, but it's easy for us to access. We recognize the foods. It's cheap as well. We're not paying lots of extra money for extra ingredients. So what we did was we had a program that was kind of similar, adapted to an Australian context, and we showed our co-designers that program, which wasn't developed to be specific for stroke survivors. And we asked them what stroke survivors would find difficult about that program and what we could do to make it easier for them. So the goal is, it's a 6-month program as well, and our participants get 10 sessions with a dietitian, me or someone like me. We have those sessions more often at the start to help get you up to the adherence rate that we would like to see you at. And then for the last 6 months, it's all just about monthly check-ins to see where you're at. And basically often my participants will say things like, oh, Carly, I failed the diet. I'm like, no, the plan failed you. So it's just about tailoring that plan to make sure that it fits in with your lifestyle, your abilities, your cooking style, how you eat, and making sure that it's really easy for you to get the nutrients that you need. So what our stroke survivors told us during the co-design process is that it's really, really important for me to understand your life story, what life looks like for you, how you shop, how you cook, how often you sleep, and make sure that we can tailor that plan to fit the way you live your life. We also made written resources that are readable for people with aphasia, including a recipe book. We've put extra built-in support for stroke-specific needs. So we've got resources for people that can only use one hand for cooking. We've got easy meal ideas for when you have fatigue and you just can't be bothered to cook. And let's be real, we've all been there. We've created checklists to help you understand how many nutrients that you're getting in, and templates for meal plans and goal setting. But I think also what our stroke survivor co-design partners really made clear to us was that all of these things need to be able to be tailored to meet the needs of the person in front of me. So that's where we're at now.
And these you can see on the screen now are just the front covers of some of the information booklets that we've put together. And our pilot trial, or what that means is that we're now testing these programs through a study that you can find further info on through the Hunter Stroke Register. And so at the moment, we've got some people who are randomized. So by chance, when they take part in the study, they are put into either the physical activity program to work to help them to move more, or they might go into the Eat for Health program. Some people are doing both the physical activity and the healthy eating program, and others are receiving general advice and education about being more physically active and eating well. So we'd love to hear if anyone's got any questions, would like to hear more about what we've been doing. Yeah, thank you.
I love this program. I just know also that it's been really well thought through, and that you're approaching it kind of like not a set in stone thing. It's in beta mode, right? So this testing process allows you to try out different ways, particularly of reaching people in their homes when people have dodgy internet problems, or they've never used video calls before, or they're just there are a couple of questions. But first, can you talk to me about how people who just aren't very good at the internet have been feeling with this?
Well, look, I've got to tell you, we've had people on this trial ranging in age from 21 to 88. So we've got people with very varying skill level when it comes to the internet, and actually some resistance as well. They're really nervous about it. But I think we've created some resources that are really helpful and easy to help people get onto the internet, but we're also super flexible. We'll call, we'll have 2 devices going at the same time. We'll talk you through it. And we're finding that as soon as you've had 1 or 2 sessions and people get into the swing of things, it's like they've been doing it all their lives.
Yeah, brilliant. We're sounding a bit like a sales pitch here, though. I'm just a bit wary of that. But whilst we're doing that, Leanne's asking how can people access the program now? So caveat here, yes, we're selling this to you. However, it's a trial. And with everything in research studies, there's no guarantee that this is the best approach for stroke prevention. We can only know that, and we can only know who it's the good approach for by doing the research study. So if you do get involved and take part, I put the link to the website for the study in the comments, so you can click through there and get a bit more information. Then you'll have a chat to the researchers and just decide whether or not the trial is right for you. And then once you're in and testing it, you are the people who are helping us know whether it's something that we want to market to people. And a little bit more on that too. Once we finish research studies like this, if it turns out there's great evidence that should change recommendations in the way, and it turns out that a program like this should be recommended as the best thing to do, then it goes in and it changes the stroke clinical guidelines that are supported by the Stroke Foundation. So you could be part of that. I don't think I've reduced the sales pitch approach though there.
No.
Emily, you've been in lockdown for ages, and I'm sorry to bring it back up again. But I don't know, I've been doing lots of telehealth appointments and seeing people that way from my place too. Have you felt like you've still been able to connect with people even though you couldn't touch them, and in an appropriate physio way?
Yeah, I think it's been a fantastic opportunity for me, because I know if we hadn't have designed it, the reason we decided to use telehealth originally was to make sure that it could be accessed by anyone across Australia, because we know there's inequities in how people can access stroke care. But actually, I as part of the co-design process, when we worked with different people to get their input, we spoke to people who had delivered other telehealth before, and they raised that it is possible to, you know, deliver good programs through telehealth, but we also had great input from stroke survivors who raised that point that was really important to make sure that you did make a good connection through telehealth to make it successful. So we've tried really hard to do that, and I found it's been fantastic in terms of I'm very lucky. I get to see people twice a week, and it's been fantastic in terms of being able to communicate clearly. We haven't had any problems. The one thing I would say, though, is that obviously I'm not there in person. So for this program, it is for people who are able to stand up and do some walking by themselves. So I haven't needed, as I might for certain people after stroke, to give them any physical assistance. And I think potentially if that we were going to be looking at that, we might have to put in some other strategies around that. But it's worked really well.
Yeah, and definitely this and other similar programs aren't intending to replace all the face-to-face stuff. No. It's intending to be an option. So, you know, you might go and see a physio face-to-face for some parts of your care, but for stuff where you don't have to do all that driving or pay for a taxi or whatever else, it's another option.
The other thing I'll mention as part of the study that we're looking at is actually after some people have been through the program, we're actually asking people to provide their feedback. So we're actually asking them how they found the program and things about how they found telehealth and whether. And hopefully when we are able to put all that together, we'll be able to give people a lot more than just my opinion of how well it worked, actually how the people who have done the program felt it worked for them. And I'm really excited to see how that's all coming together. And Carly's leading that part of the project, which is really
exciting. Yeah. And so we've also had there's surveys, but we're also doing individual interviews with people that haven't delivered their therapy session so that we get a really good and we've given them the sort of directive to say, look, we have no shame. Tell us what we need to change to make it better, because we want the next iteration of this program to be accessible and be supportive for more people, as many people as it can be.
Yeah, brilliant. Just before we move on to a slightly different study, but that's still really important in this remote approach, there's also, and Emily has been involved in this work, there's also been work going on to make sure that people who aren't at the stage where they're walking or who aren't walking, who need hands-on support, can have some options through telehealth as well as face-to-face. So Emily and Coralie English and some other people locally have been working on resources and making sure that you'll be able to figure out which approach is best, which kind of is it going to be a blended face-to-face or telehealth approach. I'll put a link to those resources that were developed around helping you decide what things to ask for in the comments, whilst Carly tells us about the food choices after stroke program. And whilst you do that, there's a comment and question from Patrick that will be really relevant to what you're going to talk about, Carly.
Oh, that's good. All right. Now I'm putting up we'll make that look nice and pretty for you. So part of my overall research for our research group is also to look at the role that diet plays.
Rudely interrupt you for a second. If you just swap displays or click use slideshow, we've got the speaker notes view.
Oh, that's annoying. I got you. So if I go...
No, I think it was within the presentation view.
Yeah, I think I've got to swap displays, do I?
Up the top, click swap displays or use slideshow. Right up just above your slides in black, next to end show.
I don't know what I'm doing here. So here, up.
Once you've got the slideshow going,
swap displays. Here we go. Look at that.
There you go.
How's that? We're back after a small technical hitch. So yes, my overall research is looking at the role of diet and recurrent stroke. And so while we were doing all the background research for that iRebound program, we found that there'd been no research anywhere done to tell us what the diet of stroke survivors looks like. And more importantly, whether the outcome of your stroke has changed what you eat or how you plan or shop or cook. So usually we start with, what do we know? Well, we know that foods like these, highly processed, with lots of sugar and lots of fats, which give you lots of energy, but not many actual nutrients, can increase your risk of stroke. Now, hopefully that's not rocket science and that's not news to you. You can tell just by looking at that diet's not going to end well for anybody. But these foods are really convenient and they're really easy for people to eat. Now, this is what a Mediterranean diet pattern looks like. So lots of plants, nuts, seeds, olive oil, and lots of evidence for improving health and lowering those risk factors for stroke. But you can see that it looks like you might need some extra work to achieve that. And so during that co-design process for iRebound, stroke survivors told us that things like hemiplegia, that affects hand grip and movement, or fatigue, or aphasia that can affect your language processing, those things can all have a huge impact on the way that people shop for, cook, and eat foods. So the current advice for stroke survivors is to eat a healthy diet according to the Australian dietary guidelines and to see a dietitian if you think you need one. So that's simple, right? But, so if you aren't a stroke survivor, I want you to imagine that you've had a stroke and that your health team are recommending some dietary changes. And so this gorgeous looking soup recipe is part of that program. Now, for those of you who are listening who don't have hemiplegia, I want you to take your right hand and sit on it so that you can't use it. Now, I want you to think about how you would go about trying to peel and chop all of those vegetables with just the use of one hand. That's tricky, right? But you're motivated and you're willing to give it a go. Now, here's the recipe. So for those of you that are listening that experience aphasia, a recipe like this with small writing, lots of steps, that's really hard to put into action. So that's the reality for you stroke survivors. You're told to eat a healthy diet to lower your risk, but there's been no research looking at what you're eating now and whether the outcome of your stroke has changed the way that you're able to eat. So any of those programs out there, the healthy eating programs that are available, except iRebound, obviously, are not designed with your specific needs in mind. So this is where my research starts. So this is the next study in my PhD is called the Food Choices After Stroke Study. And it's in two parts. So for the first part, we are asking stroke survivors to complete 2 online surveys. And that's telling us what your current diet looks like and how it's changed since stroke. And more importantly, some of the reasons why. And we're also sort of collecting information about what makes food easier or harder for you. And for the second part of this study, we've also asked people to do individual interviews with me to share their experiences about how the outcome of their stroke has changed those things about shopping or cooking and eating. So we've already completed that interview part. And so far, people have told us things like that severe extreme fatigue and having an energy budget. So only having a certain amount of energy and having to make choices about where you're going to spend that energy is really important when you're thinking about change, and that we need to make sure that we understand that for programs. Many people have told me that they eat more simply now after stroke. So not just in terms of the preparation, but also for things like the cleanup. Lots of people will choose foods that only need one pan because it's exhausting cooking and it's really difficult to face the cleanup journey afterwards. People have also told us about the types of things that they do to make food prep easier. So one of my participants was telling me that they put everything on a trolley when they're about to start cooking, and so that it's all ready to go. And they might, when they're mixing things in a bowl, they'll put it in the sink. So A, it's got some support, or B, it also makes the cleanup easier because it's already in the sink. So I guess what we're hoping is that by understanding all of these reasons why food has changed for you after stroke, that will mean that we can, alongside stroke survivors, design programs that will make healthy eating easier. And actually, in fact, I'm also already using some of the information from the interviews with stroke survivors to help develop additional resources for our iRebound participants. So the survey's still open till the end of the year. So if you've had a stroke and it sounds like something you'd like to be involved with, here's the link, but it's also just up on the HMRR website under the Participate in Research page. Also, if you would like to have a chat with me, I'll be hanging around the chat room as well from, I think, what am I looking at, 4 o'clock. And I would love to come and chat all things food with you all. So I will just stop my screen sharing. Yes. So yeah, please come and visit me in the chat room. I'll talk about food all day.
Yes, that's correct. In my experience. Thanks, Emily and Carly. I've just realised too that 2 of the co-developers of this program are actually backstage at the moment. I'm not going to just beam them live without warning. But Rachel Peak, Raymond Gray, have worked on different aspects of the trial, which kind of brings me to a comment and question from Patrick Clemenson, who's watching. He said that he did the CSIRO Total Wellbeing Diet early this year prior to his stroke. It involved lots of weighing and measuring of ingredients, and an onerous amount of food prep was involved. It became a disincentive in the end. The main advantage was that by eating the appropriate foods, you never went hungry and you did lose weight virtually without trying. I think you've answered his question mostly, which was how is the program you've developed positively different to this one if you've got one functioning hand, for example. That I know that Rachel and you have this video explaining this on the website.
Yes, yeah, we definitely do. And we also have, Patrick, rest assured, we don't weigh or measure anything really in a Mediterranean diet pattern. It's all about, I call myself the dietitian with the pencil, not the rubber. So it's all about the foods that you need to put in. And then as part of any sort of program, it's about making it work for you and in your life. So in terms of, there's not a lot of food prep if that's not how you run. So I just had a session with a participant this morning, and we worked through what she calls bench meals. So things that you can put in an omelette or on a plate, or you just pull together out of stuff that you already have. Because yes, I can see Leanne saying just deciding what and when to eat can be overwhelming and exhausting. And that's absolutely true. And I learn that from my participants all the time. That making it simple for people is the most important part. And it doesn't have to be. You don't have to. You can eat the same thing every day if you like. It can be repetition if that's what works for you. It's just about knowing those tips and tricks to get the most nutrient bang for your buck and getting that into a really short, easy space.
Well, thank you both for coming to chat. If you've got more questions for Carly and Emily, they will be available, like they've said, after this live stream session. So I'll be putting the links to their different chat rooms just down in the comments, and then you'll be able to click and go into a chat room. There's nothing to download the way that we're doing it. So we're using a Facebook Messenger Rooms link. But if you're watching on YouTube, you don't actually have to have Facebook to enter these rooms. So you'll just go into a private chat. You can ask questions. If that doesn't suit you and that's just not your jam, their contact details are on the website. So you can get in touch for a phone call instead. And yeah, you basically can contribute to creating these programs by taking part in the research. So thank you both. I'm going to kick you backstage.
Thanks for having us.
Really appreciate your time. And next, I'm really excited to welcome Dr. Rebecca Hood. Where's your, here you are. There's your window. I'm excited because Beck and I sit next to each other in the office, except we just haven't been able to for nearly 2 years. So it's nice to see you, mate.
Hey, Jill, how are you?
I'm really well. I've got a slide deck here to share. If I can click the right buttons, that'd be good. Oh, hang on. No, I was accidentally kicking Carly out, not her slides.
So,
would you, whilst I find your slides, just introduce yourself basically with a bit of context, and then I'll grab your presentation.
So before I start, I would just like to say I'm currently speaking from Awabakal land, and I'd like to pay my respects to the elders past, present, and emerging. And for those with visual impairment or blindness, I'm a white woman. I've got my hair back in a ponytail and I'm wearing glasses. Jill's got my slides up now. Thanks, Jill. Next slide. We could start. So just a bit about me before we start. So I am a postdoctoral research associate at the University of Newcastle, and I work at HMRI. And I'm currently working in the Stroke Recovery, Biomedical Imaging, and Stress Biology Research Group, which is a mouthful. And I've been investigating stroke since I finished uni in 2010. Next, please. So during my journey through research, I've had the great fortune to work with 3 of Australia's leading stroke researchers, Rowan Walker and Michael Nielsen, who lead the group that I'm currently in, and also Professor Neil Spratt, who was my PhD supervisor. So next slide, Jill. So just going back to the basics before I get into my research. So I'm just going to, sorry, there's a few animations, so you're just going to have to click through and hope for the best. So a stroke is caused when there is a blockage to the blood supply to brain tissue, and this causes a reduction in blood supply and tissue death. And so the tissue that is most greatly affected dies within minutes, and this damage is irreversible. Surrounding this tissue death, that's called the ischemic core, is an area known as the ischemic penumbra. And so this is an area of brain tissue that has also suffered a reduction in blood supply, but it sort of stays alive for a period of time after the stroke due to some blood supply networks that open up, as you can see, and these are called collateral blood supply. And so this allows the penumbral tissue, so that tissue that's surrounding the core, to sort of stay alive after the stroke. But if the blood supply isn't quickly returned, then this tissue will go on to die as well. So this area of penumbra, so the area surrounding the dead tissue, is the current where our treatments are targeting. So all of our treatments are sort of aimed at restoring blood flow to this area as quickly as possible, so that we can sort of save as much as possible. So there's a subset of patients that undergo something called early neurological deterioration or early infarct expansion. And so imaging studies have shown that this occurs due to a reduction in the collateral blood supply. And so that reduction causes the area that was at risk to go on to die. Just tell me to click if needed. Okay, sure. And so when this dies, as the stroke gets bigger, and so we want to know what is causing this reduction in collateral flow. Jill, if you could just click. Yeah, so Dr. Daniel Beard, who'll be speaking after me during his PhD, made a really remarkable discovery that the pressure inside the skull can be raised in a subset of patients. And we think that he's shown that this reduces the blood flow in these collateral vessels. And so we think that that's sort of what is driving this early infarct expansion. And so where my PhD comes into this is sort of trying to work out what is the cause of this pressure rise. And so to understand that, we have to sort of picture the skull as like this box, and it's rigid and can't expand. And next, Jill, sorry. And within the box, you've got brain tissue, you've got blood, and you've got cerebrospinal fluid. And so the cerebrospinal fluid and the blood have like this inflow and outflow to the brain. So they're always sort of in flux. And the cerebrospinal fluid also is just like this clear liquid that sort of bathes the brain and spinal cord. And so any increase in the volume in the brain tissue, the blood, or cerebrospinal fluid will cause an increase in pressure within the skull. And so there's this growing body of evidence, particularly led by Newcastle researchers, that we think that the cerebrospinal fluid volume may be increasing after stroke and causing this pressure rise. And so during my honours year, I did some research looking at the cerebrospinal fluid and discovered that there's likely a molecule released into this fluid during the stroke that causes the pressure to rise. And so the next part of the study was sort of to try and work out what that molecule might be. So we were able to obtain a number of cerebrospinal fluid samples from people during treatment for stroke. And you can see in the picture on the left, that is an MRI scan showing in the red circle. Oops, sorry, Jill, just go back. Yep, showing an area of damage. So that's a stroke. And so we did some spinal taps on these patients. So we collected cerebrospinal fluid from the base of their spine, and we ran it through a machine called a mass spectrometer. And from that analysis, we identified about 798 proteins. So next slide. So that's a lot of proteins, and there was lots to look at. And I'm not going to go through all of them. Jill, if you could click it. So here's a brief rundown of the most exciting proteins. Yeah, next slide. So finding the molecule of interest in such a large group of proteins is sort of like trying to find where's Wally, or a needle in a haystack. So we sort of tried to go about this in like a systematic way. Next slide, Jill. And so the first thing I did was look at the pressure that was obtained while we collected the cerebrospinal fluid sample. So as you sort of put the needle into the spinal column, you can get a pressure reading. And so I looked at the samples that had the highest pressure reading at the time of collection and sort of put them in order and to the samples that had the lowest pressure reading. And so those that are highlighted in red had above average pressures. Next, Jill, sorry. And I tried to look at the expression of proteins within the sample to see if I would be able to divide the samples into those that caused a pressure rise and those that didn't, so that I could look and compare the two protein profiles. Hopefully that makes sense. Surprisingly though, oh, sorry, back to Jill. Just do that. Yep. Surprisingly though, there was no sort of division based on the pressure at the time of collection, but there was this division in the samples pretty clear due to some other reason. And so I'd like to go into that, but I haven't had time yet. And so that could have been due to the time the sample was collected post-stroke or the patient's age. Like there's lots of different factors that could be. All right, next one, Jill. So the next way I tried to look at it was to actually look at the proteins with like the highest expression in the pressure raising samples and sort of look at the correlation, so the relationship between how much protein was present in each sample and the pressure we measured at the time of collection. And so the first graph on the left shows a protein called galectin-3. And I looked at that first because that was a protein that was most highly expressed in the samples, but I didn't find a relationship between protein expression and pressure. So ICP sort of just stands for intracranial pressure. If you look at the graph on the left though, you'll see something called KCC2B or CAM kinase 2B. And that's a protein that has been known to be sort of associated with the size of damage after stroke and also brain swelling, which, as I mentioned before, can be related to pressure rise inside the skull. And excitingly, we did see a relationship between expression of this protein and the pressure inside the skull. All right, next slide, Jill. Thank you. So it's like, it's too early for us to know if these are meaningful findings. And when you look at sort of those relationship graphs, it could be that it is a cause of the pressure rise, or maybe it's a consequence. So we need to do a lot more investigation into these changes. But it's pretty exciting. And so what's next? So we need to further explore the data set. I need to get more samples. We need to work out the best timing for the collection of samples, because as I mentioned, that could have been one of the reasons the samples were sort of divided. And we also need to collect samples from people who experience expansion of that infarct core. So they would be sort of like the target population that would help with the study. Next one, Jill. So how might all of this help? So if we can identify this pressure-causing molecule, this pressure rise causing molecule, we might be able to help identify patients at risk of the pressure rise, or patients at risk of early infarct expansion. It might help us look at ways we can prevent the release of the pressure rising molecule, which would prevent the pressure elevation, or we could potentially develop a therapy to target that molecule to prevent the pressure elevation. All right, next one, Jill. So it's really important in science, you're never working alone, and there's a lot of people that help out with any one project. And I've been, as I said, really fortunate to work with some amazing researchers. So I'd just like to acknowledge all the people that I've worked with in the Spratt Lab, the Baker Lab, and the Walker-Nielsen Lab over the years. And I'd also like to acknowledge the generous funding from the Greaves family through HMRI for supporting my research. Any questions?
There are some questions, and Beck, it's really fascinating to hear about the work and the level of detail that things are being looked at, and the fact that you get to have these ideas and explore them in Newcastle. People that are having strokes are generous enough to opt into research studies. Absolutely. And so this work is going to inform the stroke treatments of the future. And I just think it's really wonderful that people are happy to be part of it. Patrick Clemenson would like to know if there's commonalities between people who have increased cranial pressure, or is that still something that you're trying to really find out?
So that's still something that we're really trying to find out. So currently, it's sort of accepted that patients or people with large strokes, so like that will affect the whole hemisphere, like one half of the brain, will have these really large rises in pressure. And so they're patients that will receive monitoring for intracranial pressure. But the people that experience this early neurological or early infarct expansion tend to have smaller strokes, and they're not currently monitored for pressure because it's quite an invasive procedure. And so that's partly, why we're looking for this molecule, so that we'd sort of know which patients would benefit the most from pressure monitoring. So we're still sort of trying to understand which patients are going to have these pressure rises and what we need to look for. But there was a really, really exciting study done by a researcher in Newcastle a couple of years ago called Tom Kovacs, and he was looking at non-invasive pressure measurement. And so he made some really interesting findings in people with smaller volumes of stroke using a non-invasive pressure measure system. So if we can get that up and running, that'll sort of, revolutionize the way we can monitor pressure across all patients.
Yeah, fantastic. So there just is a lot more that goes on between when you turn up at a hospital, you're assessed for, what's happening with the stroke and scanned. Behind the scenes, there's lots of people like the teams Rebecca are working with who are also really trying to get to the bottom of how can you predict how someone's going to go. Because a stroke on a CT scan that might look the same as a stroke on the next CT scan or MRI, whichever imaging is being used, this kind of research, as far as I've understood it, so correct me if I'm wrong, is about being able to more confidently predict who needs more treatment urgently and who is going to have a smooth recovery course.
Absolutely, absolutely.
I'm glad I've understood it. It's interesting working, as a health professional, you understand enough about the science behind what happens in a stroke and then behind your treatments. But it's so great getting to work closely with the neuroscientists and some of the other researchers just to really understand what it is that we're doing.
I think we're particularly lucky in Newcastle because we have, so many people willing to help out on both the, consumer and researcher side. We've got a really, really good thing going in Newcastle.
I agree. And thanks everyone that's watching for being increasingly involved in it too. It's really brilliant to have people jumping online, asking questions. At the Stroke Research Register, we get emails and phone calls on a daily basis with people, saying, well, yes, can I take part in a trial? But each time you share with us about what you're going through, some feedback about what it was like in the research study, even if you ring and make a complaint about something, that's really useful to us because it helps us to understand, well, if that thing felt icky for you, even if it was just an admin thing or whatever, maybe that'll stop the next person from being able to come and take part in the study. And that's what can slow research down. So we really appreciate all your feedback. Thanks for your work, Beck. Just know that you can talk more and find out, more about this research's future, as well as, how these different neuroscience changes in the brain actually affect things for you as a person moving around. So when there's half an hour to chat in a chat room later, I think that it'll be easier to figure out what that means for your brain. So do take that opportunity to talk to Beck. And thank you. I'm going to push you back down into the backstage area. All this power is kind of a bit exciting. Next, Dr. Daniel Beard is going to jump on and talk about his research. I'll just bring you up. It's a pleasure to have you here. We haven't spoken in a long time. And yeah.
Hey, Jill, thanks for having me. It's a pleasure to be here.
I'm going to let you just introduce yourself and I'll hop out of the way.
Okay, thank you. I'll just share my slides. Let's see. Oh, sorry, my computer's doing something funny here.
And while Daniel's finding his slides, just remember if you've got any questions, you can put them in the comments and we'll put them forward. But again, if kind of chatting online isn't your thing, know that you can email us at the Stroke Register or give us a call. And I'm going to put the link in the comments to how you can join. If you're not already a member of the register, what it means if you join is not that you must take part in clinical trials, but it means that we keep you up to date about when there's a trial that you might be interested in. And then you get to choose whether or not you're interested before we pass your details on to any particular research team. So I'll put that in the chat. And then, Daniel, if you're still having trouble, just...
Can you see my slides?
Oh, you know what? I'm really sorry. It's my fault because I still was sharing the last set of slides. So it's not your fault at all. That was mine. You should be able to share them now.
Okay. Share. Can you see them now?
They haven't popped up just yet.
Oh, sorry about this.
That's okay. Do you want to email them to me quickly and I'll share them from my end?
Yep.
We've thrust a brand new streaming program on everyone this afternoon. So just to make sure that you're, feeling nervous before starting. Now's a really great time to have a stretch if you'd like one. And maybe tell us what you're snacking on this afternoon at home. I've realised I haven't brought a snack up. I'm going to have to go and grab one. While I'm here, thanks for saying hello, Brett in Terrigal. And also Dina, who we work with, who's a physio, is watching. She's coming in from Melbourne as well. And who else is there? Just let us know in the chat. Now we wait for the magic of the internet to send the slides. Yeah. While they're on their way, do you mind sharing a little bit, Daniel, just about yourself and your background without the slides?
Yeah, sure.
As soon as they arrive.
Sorry about it, this guy. So yeah, my name's Dr. Daniel Beard. I'm a research fellow at the University of Newcastle and a visiting scientist at the University of Oxford. So I'm what you call an experimental preclinical stroke researcher, and my main interest is in looking at new therapies to enhance the blood supply to the brain in the first minutes to hours after stroke. Sorry, just bear with me for 2 seconds. Okay, sorry about that. I've just sent those over, Jill.
And look, it's all good. The other benefit about having a live streamed event is that everyone's at home, relaxed on the couch. Barbara's eating lollies. Patrick's got fruit and nuts at hand. So there's really no problem with a bit of a delay. I've just got the slide here. So, yeah.
Yeah, sorry. So yeah, just a bit more about myself. I'm a local boy. So I grew up around Lake Macquarie and Belmont, and I studied biomedical science at the University of Newcastle, and found a really real interest in cardiovascular science and neuroscience, and I guess that's what led me to stroke, because stroke is a disease of blood flow, so a disruption of blood flow to the brain that has neurological consequences. And so that naturally led me to want to do a PhD in human physiology with, as Beck said, one of the preeminent stroke neurologists and scientists in Australia, Professor Neil Spratt, in 2015. And then I was fortunate enough to travel to get a postdoctoral fellowship at the University of Oxford. If you just click, thanks, Jill. Between 2016 and 2019, where I was under the supervision of one of the preeminent stroke neurologists and scientists in the world, Professor Alistair Buchan. And then just before the world sort of went crazy, I moved back to Australia in 2020 to start up my research fellow role and continue to work with Professor Neil Spratt to set up a small group here in Newcastle. And the work that I've been doing over that time is what I'm going to present today. So pretty much I'm a preclinical stroke researcher and a vascular biologist. And as I said before, I'm interested in how the pipes interact with the wires. So how our blood vessels interact and influence the wires in our brain. So how blood vessels affect brain function. And that's what happens in a stroke. And I've spoken to a number of people over the years, and they basically said, oh, so you're basically a brain plumber. So a bit like, if you go to the next click, Jill, a bit like Mario here. So a bit of a brain plumber. And the main vessels that I'm interested in the brain during stroke, Beck's already done a nice job introducing, but I'll quickly go over them again. And that's the collateral or bypass blood vessels in the brain. And so here we have an example shown in another way of stroke, which there's these collateral vessels can redirect the blood flow around the clot to the penumbra to keep it alive for a certain amount of time. And this is the salvageable part of the brain. And if we go to the next click, Jill, you can almost think of these as sort of like the contraflow of the brain. So you may have been in a situation where you've been traveling down the M1, there's been an accident, and they've had to put the contraflow in place to divert the traffic around the obstruction. And that's basically what these collateral vessels are doing. And they're really important. They have a really big impact on the patient outcome after stroke, in that patients that have good collateral blood flow have a larger penumbra that can last longer, better rates of reperfusion when the vessel is reopened again with clot busting or clot retrieval, and ultimately better functional outcomes. And so the saying goes that time is brain. So if we next click, Jill. And one of the key novel therapies that I'm interested in is the key to increase the flow through these collateral vessels to buy the patient more time to be transported to the hospital and have enough brain left to save when we go in to open up the blood vessel. But despite the importance of these collateral vessels in stroke, we haven't had a way to safely and effectively increase the flow through these vessels. And one particular strategy, which seems quite obvious, but is to open up the vessels, the collateral vessels, more by what we call vasodilating them. And we've got heaps of drugs that are already available that can open up blood vessels, vasodilate them. For example, glyceryl trinitrate, or GTN, which you may have heard of before, which is often used in angina or in heart attack patients. But when it comes to stroke, it's a bit more complicated than that, because the collateral vessels are just like every other vessel in the body. They respond to vasodilators in the same way. So if you give a vasodilator systemically, so intravenously, for example, it will vasodilate all the blood vessels in the body and drop blood pressure, causing hypotension, which in stroke is really bad news. It can actually paradoxically make the stroke worse, because there's no longer blood pressure driving blood to the brain. And there have been some clinical trials of the glyceryl trinitrate, which haven't been found to be effective. And we've got some experimental data showing that if you treat with GTN, if we click on the next thing, Jill, some of the work that my PhD student Magdalena Littman has been working on, we found that giving just free GTN doesn't actually improve collateral blood flow, which you can see in the graph there, compared to the control. But what we did find is that it does significantly drop blood pressure on the second, if you can see on the second graph. Sorry, yep, there we go. So it does drop blood pressure, and this may be why we're not seeing an improvement in blood flow, is because there's not enough pressure driving blood to the head, because the free drug is just going everywhere in the body and dropping blood pressure. So during my PhD and postdoc, I asked the question, there's got to be something about these collateral vessels that are unique compared to vessels elsewhere in the body. And data that I gathered during my PhD, actually, I had everything I needed to look at this, and I went back and reanalyzed it. And what I found is that collateral vessels are quite unique in that during the stroke, shear stress, which is the frictional force of the blood flowing along the vessels, is very high. So in the graph here, we can see that on B is before the stroke and M is when the stroke starts. The collateral blood vessels, the shear stress, that frictional force is way higher. It goes up to 8-fold higher. And that is also 8 times higher than the shear stress elsewhere in the body. So we've made a massive breakthrough here in that we've found a way to selectively target these vessels. And it just so happened to be at the same time that I discovered this that I reached out to a group at Harvard University who's led by Professor Donald Ingber, who produces nanoparticles that only can contain drugs such as nitroglycerin, the vasodilator, that only release the drug in those areas of high shear stress, only found in the collateral vessels. And you can think of these nanoparticles as aggregates of smaller particles, almost like a ball of sand. And when you have the ball of sand and then you rub it between your hands or shear it between your hands, it falls apart into individual grains of sand. And that's how these nanoparticles work. So we obtained these nanoparticles that contained nitroglycerin or glycerol GTN. And what happens is when they're in the normal vasculature of the body, in the normal blood vessels, they flow around and keep their cargo inside. But when they come across areas of high shear stress, such as in the collateral vessels, they fall apart and release the drug only in that area. So we can target vasodilators to the collateral vessels. And so we set up a collaboration, and we've now got really exciting data showing that these actually work on the next slide. So this is also work I've been doing with Magda. And so we can see in the first, in the left figure, that we can, by using these nanoparticles, we can significantly increase the amount of collateral blood flow compared to, this is in the white squares, and compared to the controls, which are in the black. And really, and we can do this safely. So we can do this without causing drops in blood pressure, which is shown in the right figure. We don't see any significant drops in blood pressure. And ultimately, in the next, the third figure, we can see that this ultimately results in a better outcome. So there's the final stroke size, which is shown on this graph here, is much smaller in the treatment group. So this is really exciting. We now have, for the first time ever, we have a way of targeting these vessels to improve, to harness their really powerful effect on penumbral survival and stroke outcome. So what's next? So we want to be able to study the shear stress in human collateral vessels in stroke patients, but of course we can't do that in an actual stroke patient because it is quite invasive. So what we've done is I've teamed up with two engineers, my student Nick Huff and Professor Liza Janidi, who are experts in developing computer simulations of blood flow, and we've built computer models of the human like stroke patient vessels. If we can, in the next picture that'll come up, you can see one of the models that we've built. And you can see it looks very much like the picture that I showed you earlier in the talk, where you can see the collateral blood vessels on the top of the brain that then come around. And we can use this to run simulations of what the shear stress would be in those vessels. And we can also then simulate, if we dilate or open up those vessels by so much, how much more blood would get through into the where the penumbra would be located, and will that make a difference to the survival of that tissue? So this is really, really exciting stuff. And then if that all goes well, then we would be looking at running potential clinical trials. And we think that this nanoparticle technology would be a really powerful tool to increase or buy the patient time to be transported to the hospital. And this is quite relevant for even just our local health district. So here we can see Hunter New England Health, which is quite large, and it's the size of England basically. And when I tell my UK colleagues that, they're just blown away that the John Hunter Hospital, which it's a bit small, but it's right down the bottom there, receives patients from all this area, all the way up to the Queensland border. And sometimes they have to be transported for 5 to 6 hours. And in that time, as you said, time is brain. So they could be, the patients could be losing viable brain tissue. But we think that if transported usually in the ambulance and via helicopter, we think that this therapy could be administered on the way to hospital to increase flow and preserve the brain while they're being transported to the hospital. And so this is, this is a way off, but I'm working closely with Professor Neil Spratt, who runs the stroke service at the John Hunter, to come up with these ideas and plan this if we're lucky enough to get to that stage. So I'd just like to acknowledge the following the funding sources and also the Translational Stroke Lab team for their support and awesome people to work with. And thank you for listening, and happy to answer any questions.
That's just as fascinating, the work that you're all doing. There are lots of comments. There's not so many questions, because if other people were also like me, we're just kind of too fascinated to think of a good question to ask. So what I'm hoping is that as we kind of digest this, then there'll be a vigorous discussion in your video chat room. So since also we're running a couple of minutes over time, I might just thank you very much for joining us. I've just posted in the comments section, so underneath the videos on YouTube and Facebook, links to video chat messenger rooms. So Daniel will be in one, Beck will be in one, Emily and Carly. Oh, hang on, there is one question here, or a comment perhaps from Barbara. I'll just pop it up here. Do you have a comment then, Daniel, while you're here, on whether after a short time thrombosis, could this still be helpful?
After a short time, so this therapy would need to be administered like a relatively short time after the stroke has occurred. So that's why we think it might be useful to give it in the first sort of hours after the stroke on the way to hospital. So yeah, there would still need to be the earlier, this is the thing, it's not collaterals will buy you time, but at the same time, knowing that you need to get to hospital is the key. So the earlier that onset, the earlier that the patient recognizes that there is a stroke occurring, the sooner they can get to the ambulance. And then that's when potentially this therapy could be used to make a difference.
Wonderful. Look, thank you everyone I'm going to, Daniel, just let you go backstage and catch a breath before you jump into your chat room. You did beautifully well to keep explaining yourself after those slides wouldn't share. Always feels nerve-wracking. But enjoy your chat. It's not live streamed, and it should just be a really nice experience. We'll catch you later. That's the end of our live stream presentations. Your comments and your questions are really well appreciated. Carly will be available from 4 in her chat room. There's a phone call, and I'm about to send you the number, Carly, so that you can give someone a call to have a quick speed date type chat. But otherwise, click on a link, choose a chat room, chat to a researcher. And I've also just put the phone number for Stroke Register headquarters, which is here right now at this moment, in the comments as well. So you're very welcome to just call if you're not able to get in a chat room, and I will help you. This program continues next Tuesday afternoon. There's a couple of links flying around to the rest of the program. So we would love to see you again if you're still interested. Tuesday afternoon session is looking at stroke support services. So there'll be a chance to talk to people from the Stroke Recovery Association of New South Wales, from the Physical Disability Council of New South Wales, from Head Start, ABI services, and a couple of other organisations. There'll be, again, the live chat rooms available and some presentations. And in the evening, there's more researcher chats. I'm going to jump off now and really look forward to catching you again on Tuesday. Thanks for being here.